My name is Emmanuel Bouillon, and some time ago, and during a significant period of time, I have been studying authentication protocols, and especially those suitable for high-performance computing environment. And in that study, I obviously came across a protocol called Kerberos, which is commonly used in security-aware high-performance computing centers, but which also happens to be the default authentication protocol used by Microsoft Windows Active Directory services. So this is basically the topic of this talk today, and more precisely, I'm going to discuss some implementation issues that can lead to ways of getting illegitimate access to a network. And also, I'm going to speak about some specific points we need to take care of when managing or assessing Kerberos protected information system. So if you have any question, feel free to ask as we do it. First, some preliminary notes. Who I am? Well, I've been enjoying working in the information security for a while. And short disclaimer for this exposes my own views, and especially does not involve any of my previous, current, and future employees for the next community generation. And everything is provided for educational purposes. So that being said, here is the outline of this talk. First, a few words of introduction where I'm going to draw the big picture of today's topic, what it is about and what it is not, and its motivation, why you might find that deemed worthy of interest. In the second part, I'm going to just refresh some background you probably already have, just to be sure that you have it in mind during this presentation. I try to keep this as short as possible because I know that you've been drinking from the fire hose yesterday and today is going to be the same. So this is going to be kept as short as possible. And then we'll delve into the real topic of this talk, which I called Pass the Ticket Attack. And finally, on conclusion, with time permitting, a short digression on the disclosure timeline of this issue and the interaction with Microsoft. I hope you're ready for that. Okay, a few words of introduction. So what is this about? This talk is about user impersonation in Windows Active Directory domain. That means end users with an account in the Active Directory system. I'm not going to talk about local Windows local account. Neither am I going to talk about computer's account, neither credential harvesting techniques. Not that those topics are not of interest, just that would be out of the scope of this topic. The second point I'd like to emphasize is that we are considering fully updated systems, with especially Windows Server 2008 R2 and Windows 7 fully up to date. And what I'm talking about does not require any of the commonly used backward compatibility settings that usually degrade the default security settings you might have in place. So we are considering the best scenario as a defender point of view and the worst scenario as an attacker point of view in terms of default settings of the whole Windows environment. And the last point is that I'm going to be discussing practical implementation issues in realistic environments. That means that it works, not only in demo tuned lab. It has been successfully used against production environment. And this is what makes this talk distinct from what has already been previously said about this kind of attacks, including by okay, why should you care? I guess you all have your own idea on that. For the others, credential self-impersonation plays a key role in persistent intrusion. So very often, this is one of the key enabling steps that will allow an attacker to extend his access, elevate his privileges onto a target network, to consolidate his grip on the target, up to a point where basically the full eradication becomes a daunting challenge. The second point is that we are considering an authentication protocol, namely Kerberos, which is pervasive in today's professional environments. So Kerberos is one of the most broadly accepted authentication protocols, and as I previously said, this is the default authentication used when you have deployed Microsoft Windows Active Directory environment. So if you have already logged on a Windows machine at work, you probably have already used the protocol we are discussing today. And the last point is that you probably noticed that for those of you typically that work in the test testing field, you have probably noticed that the common target has moved from Windows 2003, from Windows Server 2003 XP to Windows Server 2008 to Windows 7. And this change, this move, has consequences in terms of what we can do regarding credential theft and what tools we can still be using, especially when those environments are extremely are configured in a tighter way. So this is what this talk is about. Now the difficult part is some background information. So you probably all have already seen this kind of diagram one day or another. So the idea is just to refresh things for you to have it in mind during this presentation. This is very, very basic and simplistic view of the protocol. When considering Kerberos, basically you can, there is three main points to have in mind. Kerberos is an authentication service which is designed to authenticate users and services on the network, which is first built upon the assumption that the network is unsafe. The network is not trusted. The network doesn't have to be trusted in a Kerberos environment. IP addresses can be fake, message packets can be faked, etc. That's not an issue for Kerberos. The second point is that Kerberos is based on a trusted third party. A trusted third party, the Kerberos server or KDC, for Key Distribution Center, is trusted by every entity on the network, users and services, called principals in the Kerberos directory. And the last point, which is also a simplification, but anyway, you can consider that Kerberos is based on symmetric key and cryptographic algorithm. That means that every entity on the network share a secret key, typically for user it's his or her password, with the KDC. So basically that's the three main ideas you need to have in mind. And now how it works. You can see a KDC as providing two services. One is called authentication service and one is called TGS, and each service provides its own kind of ticket. So ticket is some sort of security token. So there is one ticket type is called TGT for ticket counting ticket. The other one is called TS for ticket service. So first, Alice wants to get a TGT. So hey, I'm Alice. I want to get a TGT. So as Alice is a good girl, she cipher a timestamp with her password. The KDC which knows Alice's password can cipher this timestamp. So verify that Alice is authenticated. And then this service is going to generate a session key between Alice and the TGS, ticket counting service. And this session key will be sent back to Alice in twice, let's say. One will be ciphered with Alice's password, so that Alice will be able to cipher it and get this session key. And the other one will be ciphered with the secret service key of this service. So at this point, Alice got a TGT and a session key. And now when Alice wants to access the service, let's say Bob, say, hey, I'm Alice, I want to access the service Bob. Here is my TGT, and here is the timestamp ciphered by the section key I've just received. And at this point, as this service knows its own secret key, this service can encipher this part, get the session key, and verify this part. And after that, this service does exactly the same thing by generating a session key between Alice and Bob and send it back twice to Alice. And at this point, Alice, which can encipher this part, can get this session key and basically send it to Bob, which can verify everything. That's how Kerberos works at a very high level. That's everything you need to have in mind for today. Just one thing, so this request is called ASREC, this is like ASREC, TGSREC for request and response, APREC for application request, APREC for application response. Note also that for these two request response messages, we don't need the rosy colored box. That means we don't need Alice's password. That means that you can get as many ticket services as you want as long as your TGT remains valid without using your password. Okay. Having that in mind, in terms of background, there is also two very old historical attacks I just wanted to introduce. Not so much because they are a real threat in today's environment, but because there are going to be some building stones that, on which we are going to design newer attacks, newer efficient attacks. So the first security concern you need to have in mind when discussing Kerberos security is called KDC spoofing. So this attack refers, as you may have guessed, to the ability to spoof KDC response. So having just the previous slide in mind, you might be thinking that KDC spoofing should not be a concern on a Kerberos protected network. Who is actually thinking that right now? So you should be thinking that, because we said that Kerberos can withstand an untrusted network, and while IP spoofing, message tampering, and SRI are things that happen on an untrusted network. So the idea behind that is that it's not enough to get a valid AS rep in order to authenticate a user. You need to go through the whole Kerberos process, which has been described earlier, to have a user authenticated onto a service. And there has been, let's say, lazy Kerberos-based authentication that were prone to such kind of attacks. Typically, badly configured PAN modules were prone to this kind of attack. There's also a point that it's not so easy not being vulnerable even in today's environment to this kind of attack, but I won't go into details on that today. The interesting point here is that Windows implementations have never been vulnerable to this kind of basic KDC spoofing attack. So that's a very good point. And how they do that, I don't know if you ever happen to look onto the network when you do an authentication on a Windows box onto an empty territory domain. You always see an ASI, but these exchanges are always followed by a TGSI for the principal corresponding to the local workstation. So this is how you prevent a KDC spoofing attack, just by going through the whole Kerberos authentication process. And that's what Windows does by default, which is great. So, and the second old school attack I wanted to mention is the one which is called TS replay. Basically, these attacks consist in reusing a previously sniffed APREC request in order to impersonate the users onto the targeted service. So this is a very old attack on Kerberos that dates back to Kerberos version 4 of the protocol. And several means of mitigation and even prevention have been defined against this kind of issue. So typically, authenticators are time-based. That means that you have a you can shorten the time window during which you can replay the tickets. Services can implement anti-replay caches. Basically, services can keep in memory previously seen tickets as long as they remain valid. And thus, you can't replay twice the same ticket. So that makes passive network sniffing insufficient, but you can still launch active man-in-the-middle attack, basically by dropping the ticket you sniffed and send it for you. But today's solution usually relies on key cryptographic checksums that based on the session key and put on the upper layer of the network protocol. Typically, that's what is happening when you use a GSS API layer above Kerberos. And I don't know any of practically working attacks using this kind of techniques today in today's environment, especially against Windows. So that's about it for the background. Then let's move on to some newer issue and more interesting stuff on the Kerberos implementation. The first one I'd like to mention is one attack that has been presented recently by people from ISEC partners at the last Black Hat US conference. I don't know if some of you were there. But basically, these guys has shown that if you use PKInit, so PKInit is, I won't go into detail about PKInit, but PKInit is an extension of the Kerberos protocol that introduces a public key cryptographic algorithm during the first phase of the authentication, which is called the pre-authentication phase. And usually you use PK-init, especially in the Windows environment, when you have smart card authentication for your user and to the So those people have demonstrated that an insider, that means someone who has a legitimate account on the Active Directory domain, can get a victim logged on under his own account by using nearly a classical KDC spoofing method. So apparently that's enough to impress girls in Vegas. But the second attack I'd like to introduce, which I think is far more powerful, is called pass the ticket. And I'm going to go into deep details on this attack just after this. So pass the ticket attack allows an attacker to impersonate the victim during 10 hours after sniffing his or her successful authentication. It does not require any valid credential from the bad guy. And it works both locally and remotely, as long as the targeted system has terminal server enabled. Question? So let's go into details on this kind of attack. So what is the approach for this attack? You need to see it, if you have in mind the two previously described attacks, as some sort of best effort mix of KDC spoofing and replay technique. So first, you start by sniffing a valid TGS rep in order to put aside the ticket service that has been claimed for the host/target machine. So you put this, you have sniffed this ticket and you store it. So now you have the targeted system with the targeted users and it's a fake password, and you've got your fake KDC which is going to play the part of the KDC, which is going to KDC spoof response of this machine. So first, when you log on, you start by a classical KDC spoofing attack. That means that when you log on to the account Alice with the fake password, the Windows box is going to send an ASREC. And then you can classically spoof an ASREC response, because you know the fake password you just entered. So this timestamp is going to be ciphered by the password you know, and you can fake the response properly. Everything's fine. But at this point, you know that inevitably the Windows box will check this TGT by requesting a service ticket for the principal corresponding to the local host machine. Right? So you're going to see this TGS rec, and what can you do from this request? For sure, you know this session key. You just generated it yourself, so that's okay. But you can't. You can't cipher. So you can generate a session key between A and B, but you can't cipher it with the service secret key. That would mean basically owning this box. So if you own this box, you obviously can't impersonate anyone on this box. So you can't build this ticket. But what you can do is just, instead of building the proper ticket, just put the one you just need previously. And what is sure is that the session key you generated has no chance to be the same as the one that has been generated by the real Active Directory server. So for sure, this authenticator is not valid in regard of this service ticket, right? And at this point, when the Windows box is going to check this ticket service, there's no way that it's going to be working. It should not be working, right? Because these two keys, the yellow key and the one which has been in the service ticket, can't be the same. I'm going to detail back what is a pack which is privileged to the certificate. So let's try on the same. So this is a two-steps attack. First, you start by sniffing a legitimate connection. So this is I have a demo environment. So I have two virtual machines. One is a Windows 7 box, which is going to be the target, and there is an Active Directory server. And the host, which is an Xbox, will be playing the part of the bad guy's machines, doing a man-in-the-middle attack. So first, you start by sniffing a legitimate connection by legitimate users. So what you will be seeing is an ASREC, normal ASREC. Then the box is going to check this TGT by requesting principals for host / the targeted system. And at this point, what you can do is just store this ticket service. You can't do anything else by storing it because you can't decipher it for sure. And but you just store this ticket service and put it aside. And at this point, the users get logged on the system, right? So, and the second step of the attack is the combination of the KDC spoof and replay technique. So we are sorry. We are going to keep on. So this is a man-in-the-middle attack. So every flows from the workstation to the server are forwarded back and forth, except the Kerberos flow, which will be dropped, and then every request will be spoofed and answered by the bad guy's machine, right? And every other flows, DNS, CIFS, and that will be forwarded to the real Active Directory server. So first, the fake KDC is going to launch a classical KDC spoofing attack, and then forge a TGS threat with the previously sniffed ticket service, right? And at this point, normally the Windows box should verify it and say, okay, this is not good, this doesn't work. Okay, let's try what to say. So this is the TMO environment. So the target real name is called VerioConnally.net, and the victim's account is called Paul, with his own real password is very good PWE, right? So this is I have a Windows 2008 R2 Active Directory server, and here is the Windows 7 box, and my laptop is just launching a classical man-in-the-middle attack just by IRP cache poisoning. So right now, my laptop is just forwarding flows between the workstation and the Active Directory server. Nothing is wrong. And I'm gonna sneak the network. And I'm gonna sneak the Kerberos flow. Okay, now let's imagine Paul arrived at work early in the morning, well, 10:30, and logged on with his legitimate password. Okay. So Paul starts working. Okay, now it's lunchtime. Paul, as a good guy, is going to lock his screen. Okay, let's see what the bad guy has made. This shows the tickets that were sniffed during this successful authentication session, right? So this is the TGT, but what is really interesting is this one, which shows the tickets for the host / Windows 7.0.net, which is the one used in order to check for KDC spoofing attack, right? And now I'm going to drop. I'm going to drop. Keep on forwarding everything, but just dropping Kerberos flow, and my fake KDC is going to reply to this kind of request, right? So I've chosen a quick this password as a password. And now let's imagine that the bad guy popping into Paul's office and try to log in with QRT as a password. That's how it works. So now let's imagine it's late in the evening, well, 4:30, and Paul logged off. And let's imagine the bad guy is not physically in the building, but is connected to the company's Wi-Fi network from the outside, from the car park, for instance. Does it work remotely? That's the question. The idea is that if you have TS enabled, So in that sense, we can say it still works remotely. This is argued by Microsoft, but I still think that we can say that in some circumstances it works remotely. So, you can change the password if you want. Oops, QBC. Sorry. So, according to me, that's an issue. That's even better. I knew you'd like that. Okay, let's go back to the talk because I'm going to discuss an interesting part about implementation issues and tools involved in this kind of data. So, first, there are some significant changes between Kerberos implementation when you move from Windows Server 2003 in XP to Windows Server 2008 R2 and Windows 7. There are changes in the default settings you will find in the deployed environment. The first one is really good one, that this is disabled by default, which is really good news. Anyway. And another point which is really important to have in mind is that now Kerberos Flows defaults to using TCP and not UDP anymore. So this is quite annoying when you do man-in-the-middle attack and spoofing. But in a sense, it was already the case in realistic Windows Server 2003 and XP environments, because when you have big Kerberos package, which is quite always the case when you have realistic environment with lots of groups and GPUs and all that stuff, the XP machines and Windows Server 3 machines were already using TCP instead of UDP. So the thing is, it was possible to force Kerberos UDP based to TCP by just spoofing a Kerberos error saying sending this kind of Kerberos error message. Okay, this is spoofed, so it was possible to force UDP to TCP, but unfortunately it's not possible to force UDP when when it's using TCP. So you need to cope with TCP. The second point is that default crypto system has moved from R4, HMAC, MD5 to AES 256. And also, in terms of using this attack, I've noticed that, according to me, it appears that especially Windows 7 seems to be far more robust against ARP cache poisoning. You need to insist more. I don't know if you do against that. Maybe I'm getting old, or maybe Ethercat is getting old. But you still can use Ethercat to ARP cache poisoning in Windows 7, but it's just not work as well as it used to. So the other point, next slide, is about tools involved in this kind of attack. The tools I've used to implement this kind of attack. So Kerberos is an ASN.1 based protocol, described protocol. So if you look at the IRC, at the end of the IRC, you have the whole ASN.1 protocol description. So that means that basically you need to use this kind of library if you want to easily work with Kerberos packets. There are several ways to do that. You might want to use CAPI because CAPI allows you to manipulate ASN.1 structures, but I really find it not so much convenient. I love CAPI, but not for that. So this the Kerberos module I've written is based on Python ASN1 modules. So this is available at this URL. For man-in-the-middle attack, I'm fond of Ethercat. I'm using it for ages and it works so well. And the interesting point is that how do you selectively spoof TCP connection? There are several solutions for that. Typically, you might think at MU XTCP, probably. But maybe I've used a feature of SCAPI, which is called automaton. Maybe you don't know this feature of SCAPI that allows you to build deterministic automata within SCAPI. With this, it is quite easy to build a fake, wrong, server-side TCP/IP stack, but which is enough, simulates just enough of a TCP/IP server-side to make the Windows box happy with this kind of server. And that allows you to selectively spoof TCP connection properly and go up to the end of the data. The last point, I mentioned that there are several changes in the crypto library for Kerberos implementation in Windows 7, for instance. So if either you code it on yourself, far more easier ways to use already existing cryptographic library included in popular Kerberos implementations, and I would recommend Heidelberg to do that. So basically that's how it works and what I've been using to implement this kind of issue. Okay, what can be done? So the first point is that if you let anyone messing around with your layer 2 without getting caught, then I mean you are already into deep trouble, and maybe this kind of issue are not your most important issue. So if you don't, protect your layer 2 layer. The second point is that shorten the service ticket lifetime, which is by default 10 hours. So last week I met someone from Microsoft that said, okay, this is not true anymore. Default ticket service lifetime is 1 hour, not 10 anymore. This is wrong, I've checked, I've double checked. The default ticket lifetime in a Windows Server 2008 R2 is still 10 hours. 600 minutes. Right? You can see in your configuration. So activate your logs on Kerberos related events, both on the server side and on the workstation, and of course have a look at it. And also think twice before implementing cross-domain trust relationship in a Kerberos environment. Kerberos allows you to define a trust relationship one way or two-way trust relationship between Kerberos elements. I tend to think now that there are probably a better way to do this kind of to solve this kind of issue. Typically using claims-based authentication and Active Directory Federation service. This is far more powerful and restricted. That's about it. And before the conclusion, just a few words on the disclosure timeline of this kind of issue. So, Microsoft Windows has been given the full documentation, explanation, and demo videos of this issue in 2008. So first they asked for more time to investigate. And after, I don't remember a month, they came back saying, okay, this is normal Kerberos behavior. Okay, why not? Then, at the end of this year, I started discussing this issue and typically made a private demo to a Microsoft expert, which now is, I think has changed. He's not working for Microsoft anymore. And he basically said, okay, that's really a bad issue. Microsoft Response Center is going to be back to you extremely quickly on that issue. I never heard anyone getting back to me. So basically I had this nice code, I was happy, I was able to impress my friends and girls with this kind of issue, that's just right. But then, I don't know if you remember this, I don't know if you've seen this TV advertisement about Thibault security. This is a guide, it's a French advertisement. This guy basically said that Windows 7 was his idea, and Windows 7 is the best and the most secure system in the world. And for that, he would deserve his own statue. So seeing this advertisement, I was thinking, okay, they should have solved the issue have been given to them. So it took me some time to just verify it, and at the end of the year, basically, no. I discovered that neither in Vista or Windows 7 they solved this issue. So after months, I just sent everything again to Microsoft Security Response Center with demo video, source code, documentation. And after weeks and weeks and weeks, they said, okay, this is a valid issue. Cool. However, we do not consider this as a vulnerability. No CVE will be claimed. So we've reached the level of valid issue, which is already nice, but this is not a vulnerability from their point of view. Just after that, some Italian researcher released code, publicly released code, based on protection I've made previously. Thankfully, this code is, due to the reason I've described above, is not harmful or is harmless in most cases environment. So, from my point of view, there's no sign that this is going to be solved quickly. Okay? Conclusion. Don't get me wrong, Since Windows 2000, Microsoft implements Kerberos as its default authentication protocol. This is a great thing. It greatly improves security compared to previous mechanisms, so that's really a good point. And also there's something I'd like to say that the default settings are still more secure than the default Unix implementation settings. I don't know if any one of you have already managed a Unix-based KDC, for instance. Okay, so I won't go into detail. But if you have no clue on how to tune a Kerberos key distribution center or Kerberos, I would recommend to use Active Directory as your KDC. But there are still implementation issues that allow to fully bypass authentication. Recent changes in the default Kerberos implementation do not prevent this attack, and it is not considered as a vulnerability by Microsoft Security Response Center. So better activated and monitoring logs. Thank you very much for your attention, for being here so early. There are some sample codes available on the net. I welcome your question and I welcome your feedback on this topic. Here is my email address. You can contact me if you have any further question and if you want to discuss this topic. I'm really fond of discussing this kind of issue. That's about it. Thank you very much.
One more question. How would the attack look like in the log?
Yes, usually I always have this question. The question is, how does it look like in the log of the system? So, by default, from the Active Directory side, you see nothing. And on the local workstation Windows 7 log, you see successful authentication. That's how it works. And what is interesting is that if I come back to this patch thing, is that I've mentioned this at a certain point. Okay, here I mentioned this privileged attribute certificate. Basically, this is a Microsoft-based structure that allows Microsoft to put inside tickets Windows identity information like SID and that stuff. And what is funny is that no matter what kind of username you put here, at the end, you will be logged on the identity which is in this patch structure. That means, basically, you can say, here I'm Alice. If the sniff ticket was an administrator ticket, at the end, you will be logged as administrator. And the logs will show that you are logged as administrator. That's it. It should have been even better. No, that's how it works. So that's always funny. You log an Alice password, and then you get administrator of the machine. So if you sniff administrator of ticket service, you get administrator of the machine. And that's what is appearing on the logs of the system. Any other questions? Oh, yeah, right.
I don't know if you remember the project. Did you mention that the guy who's attacking the victim needs to be involved, needs to have a valid account?
No. The guy who's attacking does not need anything except being able to do a man-in-the-middle attack on the Kerberos flow. I don't know Alice's password. I don't need an account on the domain. That's a very important point. This is a full. Typically, you plug in on the valid network, and then you launch your ARP cache positioning, sniff Kerberos ticket, and then launch your attack. You don't need any. It's not an insider attack in terms of I need a valid account on the domain. No, nothing on the domain. You don't know the domain. You just need to know the IP address or you want to attack. That works perfectly. I would say live, Wi-Fi, anything you want. So, yeah.
So why do you think Microsoft is not reacting?
That's also the first argument is that according to them it requires physical access to the machine, which I disagree with that. And the other answer is that I don't really know, because I understand that there are far more urgent issues to solve, because this is not as bad as the 0-day on IE for sure. But still 3 years or 2.5 years to solve this kind of issue without telling anyone, that's still not reasonable. But on the other hand, this is how they behave. And I've been disclosing vulnerabilities with Red Hat, Apple, lots of open source projects. All that stuff. Every time it goes quite well. But this one is just awful. And each time I met someone from a Microsoft response, each time they say the same thing. Oh yes, this is a real issue. We will get back to you, etc. And after that, I hear no more. So I don't think that's really. Basically, that's one way responsible disclosure from my side, and they don't react on that yet. I've been told that they are working on it, especially since there are code released by the Italian guy. Basically, as long as it's not implemented in Metasploit and it's not heavily used, they really don't care. That's my problem.
This kind of attack you need to have man in the middle, like with ARP cache poisoning. Wouldn't it be the easiest thing to detect ARP cache poisoning? If you monitor that, then you could also detect this attack.
Yeah, so you need
attacks
exactly.
as well.
So you're right. You need management attack on the Kerberos flow. The easiest and most commonly used way to do that, at least for me, is ARP cache poisoning. It works quite well. Usually that's fine. We could discuss how we could do that with other ways. Typically, Windows box is using DNS to find this KBC. And have you ever played with dynamic updates on Microsoft Windows DNS server? That opens doors to way to broaden the scale of this kind of attack. But for sure, if you can't do this kind of man-in-the-middle attack, you can't launch the attack I just described. And the easiest way to do it is to use ARP cache poisoning. And I would recommend anyone to avoid and to catch anyone with playing around with ARP cache, because that's not good, and that's really an issue anyway. And usually, if you don't do that, you have other problems far more, I would say, important than this one. And if you prevent, let's say, if you have an IPsec from every socket to your default routers, for instance, this kind of attack won't work. And usually, when you have very tight environments, which take care of this kind of issue, they tend to protect their relay to the. So it requires man-in-the-middle attack, and ARP cache poisoning is, for me, the easiest and lamest way to do it. But this is an interesting issue, how we can broaden these attacks and how we can divert and have this Kerberos flow even when we are not on the local LAN of the target system. But that's beyond the scope of this. But that's interesting. Any other questions? Yeah.
I'm not sure if it is a valid one.
Sorry. Yeah.
Is it possible to connect to an additional server with a spoof ticket? Because every time I need to request a ticket to a specific server.
Yeah. So the question is, if I understand it properly, once you've done this attack, can you connect to another service? Is that it? Is that right?
I log in locally,
Yeah.
and then I want to use an additional service, mail,
Exactly.
file server, or something.
So there are two cases. Either you already got the ticket service for this service. Either you didn't. If you can't claim a new ticket service with this attack because your TGT is not valid from the real Active Directory point of view. So the quick, if you don't have previously the ticket, you won't be able to get a new one. But for instance, if when you log on, you have your home directory mounted, you lock your screen, and I unlock your screen with this attack. I can still browse your remote file because your ticket service is cached. So if you can access services for which you already have a ticket service, a valid ticket service, for which your user has already obtained a ticket service. You can't get a new one with the TGT you've just been provided by this attack. So for example, if I unlock, usually when you unlock a user this way, you can access his remote file. Because the ticket service for CIFS / server side is still here and valid and cached locally. But I can't mount a new file system, for example, for which I didn't get a ticket service.
It's also true if you log off, if the client logs off, and then you log on again.
In that case, no, it's not true, because when you log off, it will reclaim every ticket. So you can reboot the machine, you can log off, the attack will still work, will still be working, but I won't be able to access new tickets. And at the start, have no valid ticket service. Just ask. So, but if you unlock the user, which already has a ticket service in cache, then that's indeed a difference. But what's funny is that you can reboot the machine and still you can still log them for 10 hours, so you have time.
Two questions. One is, you said that you should reduce the lifetime of the ticket to 1 hour, for example.
No, even less. You don't care.
So, does it have an impact on the network if you set it to, for example, 5 minutes or so?
Yeah.
So what's the best value to set that lifetime?
So the question is, okay, one of the recommendations is to shorten the ticket service lifetime. What is what I would recommend? So, first of all, Kerberos flow are very, very light. So what would happen if you do that? Is that you will, let's say you say 1 minute. Your ticket service will be renewed transparently every 1 minute. This is a very, very light. This is very, very small network flow. This is very, very light. I never seen. I deployed Kerberos in big centers a long time ago, and I was very afraid of the, burden of the server, especially in the morning when people were logging and all that stuff. In fact, that's rubbish. Usually, you have several Kerberos servers. So even 1 minute, I've never seen an Active Directory server fall down because of this kind of burden. So that's, for me, except maybe if you have a very, very big number of users and a very, very small bandwidth between your workstation and your Active Directory server, which is not a good idea anyway. The flow between your workstation and the Kerberos part in the flow between your workstation and the Active Directory is extremely small compared to every other RPC, CIFS stuff, and ADAP. That's nothing. So you can shorten it to 1 minute. That's just fine. I've never seen a production environment where it was raised an issue. So that's a very interesting question, and no, for me that's okay.
Second question: is it also possible to mount the default share of the machine, not just log on via the terminal services or go to the machine locally?
No, it's not, because no, it doesn't work this way. You need to have the interactive logon.
Yeah.
And
PSExec,
it won't work now. So the question was, okay, can you connect to the machine with PSExec, for instance, to using this kind of attack? The answer is no. Or use SMB client and all that.
Okay, so if there is no more questions, I mean, I'm pretty sure Emmanuel will be around for the
Yeah,
rest
we'll
of
be
the
around
day.
if you have any further questions.
So if
Thank you
there's
very much.
no more questions, thanks a ton, Emmanuel.
Thank you.
And we're going into coffee break until 10:20.